What's up, pre-calc? Welcome to the final video of the year. Sorry, the final video series, the final module of the year. You guys have made it all the way through fourth quarter, and now all I have to do is this module, which is for the 9.04 quiz, and then you take a practice quiz for module 9, and then you do the module 9 test, and then you're done with math for the year. So great job if you've made it this far. Guys, I'm proud of you for having the self-discipline to learn math, not only in the midst of this crazy pandemic thing we're all living through, but also when the sun is out and summer is right around the corner and all you want to do is not school stuff. So I sympathize with you and I'm proud of you for, like I said, having the self-discipline to sit down and learn and do math. So good job, +1 respect to all of you who are here. Let's move on. But, oh, by the way, I'm sorry this video series is late. I know I said I'd have it out a week ahead of time. I'm a day or two late on this one. I'm sorry, I'll make it up to you somehow. Okay, 1 minute in, I haven't even started the math. Another thing I have to say is, if you look at the Canvas lesson for 9.04, it talks all about discontinuity and types of discontinuity, how to identify them, and so forth. And we talked about that at the start of the year, like in first quarter. And then I looked at the quiz for 9.04, and I noticed that there's only one question that has to do with discontinuity. The other questions are pretty much just about limits, and there's one question about an asymptote. So I'm going to try and make this video, there might be 2 or 3 videos here, I'm going to try and make them more to prepare you for the quiz rather than to teach you the stuff that the Canvas lesson wants to teach you. Okay? So if you look at the Canvas lesson and it's totally different from what I'm teaching you, that's why. I'm trying to help direct you towards the quiz more because that's the thing that you're graded on. Okay. So we have here a piecewise function. We dealt with a piecewise function in the last video. We're going to do a lot. This is, of course, a different piecewise function in the last video. And we are going to calculate some limits. Here are the 2 limits that we are going to calculate. We're going to do this without graphing. Okay? You'll notice I drew an x-axis over here. That's just so that I can read this piecewise function properly. Okay, so that I can visualize it. So I drew an x-axis. I see that my function is, if x is less than -2, let's say 0 is here, let's say -2 is here. If x is less than or equal to -2, I'm graphing this function 3 to the x. So I'm going to put 3 to the x in that zone from -2 down. And then if x is between -2 and 3, so I'll put +3 maybe right there. And in this zone, we are graphing x squared minus 5. Or my y value is x squared minus 5. And then everything from 3 up, I am graphing this rational function, 3x minus 5 over x minus 2. Okay, so this just helps my brain think about what x values get plugged into what piece of my function. Okay, so maybe that'll help you too. You don't have to draw this if you don't want to. It just helps me think about it because sometimes looking at this stuff confuses me and too many details for my brain. Okay, so let's start with this first limit. As x approaches 3, what value does my function approach? As x approaches 3, from what direction? This is a regular limit. It's not a one-sided limit. As x approaches 3 from both directions, what value does my function approach? And we learned in the last video when I was showing you on the graph, and we were tracing the graph, in order to find this limit, we have to know what both of the one-sided limits are. As x approaches 3 from the positive side, and as x approaches 3 from the negative side. What are those limits, right? So as x approaches 3 from the positive side, we're plugging in values of x that are greater than 3, getting closer to 3, and seeing what happens to our function. So as we plug in values of x greater than 3, getting closer to 3, what's the value of our function? So we see already that we need to substitute 3 in for x into this function because this function defines all the values of x greater than 3. So if we approach 3 from this greater side of 3, we need to substitute x into this function. That's why I drew this diagram so we could see that. Okay, just looking at this regular notation over here, it's harder to see. So basically this is saying substitute 3 here. Okay, so I'm going to just calculate that out. That's 3 times 3 minus 5 over 3 minus 2. 9 minus 5 is 4 divided by 3 minus 2 is 1, so that is going to be +4, right? Oops, did I put that? No, I didn't put that in the wrong place. That's in the right place. Okay, now let's do from the left. As x approaches 3 from the left. So as we approach 3 from the left, now we're here, right? So I need to substitute 3 here. So that is 3 squared minus 5. 3 squared is 9. Minus 5 is indeed 4. So we have a left-sided limit and a right-sided limit that equal the same value. Therefore, the limit as x approaches 3 of our function is positive 4. It exists. Okay, does that sound familiar? I hope so. We're doing the same thing we did in the last video, just this time without a graph, just by substituting values in. Okay. Now let's do as x approaches negative 2 and see what happens. Okay. As x approaches negative 2, well, I need to know from what direction. This is from both directions, so in order to figure that out, I need to calculate as x approaches negative 2 from the positive side and as x approaches negative 2 from the negative side of f of x. I need to figure both of these out first in order to get my two-sided limit, right? All right. As x approaches negative 2 from the positive side, there's negative 2. I approach negative 2 from the positive side, which means I need to substitute my x value into this function, right? Numbers greater than negative 2, that's going to be x squared minus 5. So I need to substitute negative 2 into, oops, don't know why I put that parentheses there. Negative 2 squared minus 5, negative 2 squared is 4. 4 minus 5, that's going to be negative 1. Okay. Now as I approach negative 2 from the negative side, here's the negative side of negative 2, right? Approaching negative 2 from the numbers less than 2, that's this function, 3 to the x. So this is going to be 3 to the power of negative 2, which if you remember, a negative exponent just means this is, let's see, 1 over 3 to the positive 2, right? Remember, that's how you deal with a negative exponent. You just make a positive exponent, but you put it in the denominator, which is 1 over 9. Okay? Plus 1 respect if you know what 1/9 is as a decimal off the top of your head. Do you know it? 0.1 repeating. Any single digit integer over 9 is just the repetition of that integer. So 3/9 would be 0.333, 5/9 would be 0.555. I think I've said that already. So, but that's besides the point. All we need to see is that the limit from the left side and the limit from the right side do not equal each other, right? So what do we know about the regular old limit? Just like in the last video, does not exist. Okay, so we don't need to draw a graph. All we need to do is we need to know which of these pieces does our x value get substituted into, and if they are equal to each other from the left and from the right, then our limit exists at that value. And if they are not equal to each other, like negative 1 and 1/9, then we say that that limit does not exist. Okay, so a lot like the last video, just this time without a graph. And that covers, what, 1, 2, 3, 3 out of 5 of the questions on your quiz are a lot like that. So if you got that, you're already almost ready for your quiz. Okay? All right, I'll see you guys in the next video. Bye.